What are some typical values of the speed of sound in gases, liquids and solids? Remember that sound is a longitudinal wave and it needs material, or a medium as we say, to travel through. It's particles that bump into their neighbours, transferring a pulse of energy along the material. So let's take a look at some typical values for gases, liquids and solids. Let's take air as a good example of gases, which is a mixture of oxygen and nitrogen basically. And in air, the speed of sound is 343 meters per second. Now that's in dry air, has no water vapor in it at 20 degrees Celsius. Let's take water as a good example for a liquid. And the speed of sound increases quite significantly to 1,484 meters per second. Now a solid. How about iron? The metal iron, and the speed of sound in iron is 5,120 meters per second. A huge increase from the speed of sound in a gas or in a liquid. So what's the difference? What's actually happening here? Well, in air, the particles are far apart. Really far apart compared to a liquid or a gas. And so as we go down here, the particles become much closer together. So we can say particles closer together. But also in air, as well as the particles being so far apart, and so that's why it takes a longer time for a particle to bump into the next particle, which is going to bump into the next particle, and so on. The bonds between the particles, well, there are hardly any bonds in a gas. So we can say plus very weak bonds. Think of the bonds as springs between the particles. If you connect these particles with strong springs, then if you push this one, it will quickly transmit the force to the next particle, to the next one, and so on. And so gases with hardly any bonds between the particles have quite a slow speed of sound. As you go to a liquid and a solid, however, the bonds get much stronger. So the particles get closer together, plus stronger bonds between the particles mean that the speed of sound gets much faster as we go to liquid and to a solid. Now, just for fun, let's take the extreme example. So this is diamond. Diamond has got some incredibly strong bonds between the carbon atoms. And because those bonds are so stiff, so strong, the speed of sound is huge. 12,000 meters per second in diamond. That's pretty fast. That's nearly 24,000 miles per hour. So those are typical values for the speed of sound in a gas, liquid, and in a solid. By the way, if you are asked to state some typical values for the speed of sound in a gas, liquid, or in a solid, then you can use just approximate values for these speeds. So 340, 1,500, and 5,000 meters per second are absolutely fine.